Hello class, in this video we'll be learning how to graph linear equations. In order for us to graph linear equations, we're going to need to understand what are some important features and useful information required to do so. We're going to learn how to actually calculate and determine the gradient from a linear equation, as well as finding out both the x and y intercepts. And by putting all these informations together, hopefully we'll be able to graph a linear equation. The first thing that I'll do in this video is I want to review quickly what is a linear equation. We defined a linear equation as an equation where it contains either one or two letters or two variables, and these letters are always raised to a power of 1. So that just means that you've got 1 as the exponent, but oftentimes we don't often write that. And this is actually illustrated using these examples over here. Notice that all the linear equations, you've always got to the power of 1, which we don't actually write at all because that's just default. Whereas all the non-linear equations, you will have different exponents, that being to the power of 2, 3, 4, etc., etc. Another defining feature of a linear equation is that the graph of a linear equation will therefore produce a linear graph, meaning a straight line, and that is just illustrated on the examples on the right. Now, in order for us to successfully graph a linear equation, we need to kind of find out three pieces of information. That is the x-intercept, the y-intercept, and the gradient. So the x-intercept is essentially the point where the graph, the straight line, crosses through the x-axis. So that over there is the x-axis. So in this example, that's where the x-intercept lies. Another important piece of information that you need to understand is that during the x-intercept, or where the x-intercept occurs, the y value of that point is going to be 0. So notice that the vertical position for that particular coordinate is going to be equal to 0, since that over there is going to be the origin. Another important feature is going to be the y-intercept. So the y-intercept is defined as the value where the straight line crosses through the y-axis. So that over there is the y-axis. So that's plotted over here. And at this particular point, notice that your x value is going to be equal to 0. And whenever you're trying to graph your linear equation, it's really important that we actually express the intercepts in coordinate form. So that's what I've done over here, like so. The final important piece of information for us to understand is going to be the gradient. And the gradient essentially refers to the slope or the steepness of the graph, and that is given by the rise over run. So something that you should have already been exposed to last year during year 9. Now, the definition of a gradient is that the value of the gradient will tell us how many units we either need to either increase or decrease by, and that will be determined by the sign of the value for every 1 unit you moved to the right. Okay, so let's just take this particular point over here as an example. So in this case over here, if I wanted to find out what is the gradient from this graph over here, notice that for every 1 unit I move to the right, because that's what the definition is, I only move 1 unit up. So therefore, the gradient in this particular graph over here is going to be equal to 1, because it only moves up once for every 1 unit it moves to the right. And notice that the gradient is pretty much consistent or the same if you take any points on the actual straight line. The next thing I want to talk about is the different forms that linear equations can be represented in. So a linear equation can be represented in 2 different ways. One of the ways that it could be represented in is in the slope-intercept form. So that's given by the form y is equal to mx plus c. And another way that this could be represented is in the standard form, where it's represented in the ax plus by is equal to c. So I'm just going to give you some specific examples so you can kind of see the differences between the slope-intercept form and the standard form. And one thing that I want you guys to understand is that we could actually convert between either forms. Now, the reason why we need to learn these 2 different forms that a linear equation can exist in is that these 2 equations come with their own set of advantages and disadvantages. So for one of the linear equations, it could easily allow you to find certain features than the other. So for the slope-intercept form, we could easily identify what is the y-intercept and what is the gradient. Whereas for the standard form, we're able to kind of easily find out what is the x-intercept and the y-intercept. Now, this doesn't mean that we can't find out what is the x-intercept when it's in the slope-intercept form. And it also doesn't mean that we can't find out what is a gradient. It just means that there might be a few extra steps that we need to do in order to actually work these out. So both of these forms come with their own advantages and disadvantages. Now we're going to be moving into the most important part of today's lesson, which is how do you actually graph a linear equation. Now, in order for us to graph a linear equation, we need to know two important pieces of information or two known coordinates. There are three ways that we could actually graph a linear equation. One of the ways you would have learned during year 7 and 8 is by completing a table of values and substituting x values in to find out the corresponding y value, and then plotting those points and connecting a straight line in between those dots. Now, that particular method won't be kind of acceptable in year 10. I'm going to show you other ways in this video over here for us to graph a linear equation. One of the ways is by identifying what is the gradient and using the gradient to therefore find out what is the next coordinate from the y-intercept. And the last method is by identifying both the x and y intercepts. So now I'm going to show you how do we graph linear equations that are presented in the slope-intercept form. When it's presented in this form, we could easily identify 1, what is the gradient, and 2, what is the y-intercept very readily, okay? So the value of m tells you the gradient, the value of c tells you what your y-intercept is. So therefore, in this particular example over here, I can readily identify that my gradient is going to be equal to -2, and my y-intercept is going to be, in this case, +6. Now, when you're writing the y-intercept, it's really important that we write it as a ordered pair of coordinates. So therefore, you'd write it like this, because that over there, remember, the x value of the y-intercept is always going to be 0, and 6 is obtained from this equation over here. So it's going to be 0, 6. If we were to graph this using the gradient and y-intercept, what you want to do firstly is you want to plot the y-intercept first, like so. So that over there is where the y-intercept lies. Now what I'm going to do is I'm going to now use the gradient to find out the next coordinate, so that therefore I can draw a line in between. So because my gradient is equal to -2, what that tells me is that I need to move down 2 units for every 1 unit I move to the right. So therefore, going down 2 units for every 1 unit I move to the right. So therefore, another coordinate that exists on the line is this one over here, where it's going to be 1, 4. Now that I know the second coordinate, I could just easily draw a line in between these two coordinates to form its graph. So therefore, this is going to be my graph over here, and I could readily tell from this graph that my x-intercept is going to be at where x is equal to 3. Let's now look at a second example. So in the second example over here, notice that I've kind of switched positions of the terms, but the same concept still applies. We need to kind of identify what is my gradient. My gradient is always going to be the value that's in front of x. So in this example over here, my gradient is going to be equal to +392, which is the same thing as 1.5. And my y-intercept is going to be equal to -6. So I'll write that as 0, -6. Using this example, I'm going to show you how we can actually graph using the y-intercept and gradient. So what we do first is we'll plot down the y-intercept onto our graph. So that's going to lie over here. Now, please recall that the gradient is equal to rise over run. Okay, and we could actually therefore use this value to determine what's the next coordinate on the actual straight line so that we could actually draw its graph. So starting from the actual y-intercept itself, it's telling us to move up, rise by +3, okay? So by moving 3 units up, this is what it would look like. And we need to therefore move 2 units in the positive direction, because that's +2. So we therefore move to the right. So if I move 2 units to the right, the next coordinate is going to therefore be 2, -3. And now all I need to do is just draw a straight line connecting these two coordinates, like so. And from this, I could also find out that my x-intercept in this example over here is going to be when x is equal to +4. Now, using these two examples, there are some trends that I want you to understand. Now, the graph is always going to be moving in the positive direction, okay? So that's in this particular direction when the gradient is a positive value. So that's what it means by m is greater than 0. Now the graph actually goes in the opposite direction when your gradient value, your m value, is going to be a negative value. So that's why it means m is less than 0. So far I've currently showed you how do we actually sketch a graph from using the gradient and y-intercept form when it's presented in the y is equal to mx plus c general form. But now I'm going to show you how do we actually plot the graph from the x-intercept and y-intercept, still using the y is equal to mx plus c form. So in order for us to do this, we need to solve for our x-intercept first. And the way that we do that is by substituting y is equal to 0, okay? Because we know that when it crosses the x-axis, the y value is equal to 0 at that particular point. So if I substitute y is equal to 0, this is what my equation would now look like. And now I'm just going to be solving for x, okay? So let's keep x on one side and move all the other terms on the other side. So I'm going to move the 6 over to the other side. So what I'll do is I'll undo 6 by subtracting both sides by 6. That will therefore give me an equation, negative 6 is equal to negative 3x. And now I'll just get rid of the coefficient by dividing both sides by negative 3. Two negatives cancel each other out, so therefore x is going to be equal to positive 2. So that over there is going to be my x-intercept. So I'll write it as 2, 0. Now, I know that when it's in the y equals mx plus c form, that over there, 6 is going to be my y-intercept, but I'm just going to substitute x equal to 0 so that you can see how we actually came about this. So by substituting x is equal to 0, we know that any number multiplied by 0 is equal to 0. So therefore, you're left with y is equal to 6, and hence that's going to be a y-intercept. So now, now that I've calculated both my x and y intercepts, all I need to do now is just plot these 2 points and draw a line between, and therefore that's going to be our graph. Let's go through another example. So in the equation y is equal to 3x over 4 plus 3, let's find out what is the x-intercept. So we do this by substituting y is equal to 0. So therefore, by substituting y equals to 0, this is what our equation would look like. Let's move the 3 constant over to the left-hand side. So we'll undo it by subtracting both sides by 3. So that would cancel this over here. This is what our equation would now look like. Now, notice over here, we've got a 4 as the denominator. We can actually undo this by doing the opposite. So we will multiply both sides by 4. So by doing that, it would cancel out the denominator. And now we're left with negative 12 is equal to 3x. To get rid of the 3 in front of x, we'll divide both sides by 3. Hence, x is therefore going to be equal to negative 4. So that's going to be our x-intercept. Now, for this particular example, we don't really need to show working out for our y-intercept because remember that over there is our y-intercept. So therefore, our y-intercept is going to be given 0, 3. Now that I've worked out both of my x and y intercepts, let's plot these onto a graph. And now just draw a line between these 2 coordinates over here to draw its graph. And so therefore, that's going to be our answer. Now that we have learned how do we graph equations in the slope-intercept form, let's learn how to graph equations that are expressed in the standard form, aka the intercept form. When linear equations are presented in the standard intercept form, they are often in the form ax plus by is equal to c, where the letters a, b, and c are numbers. One of the main advantages of the standard form is that it will allow us to easily work out what is the x-intercept and y-intercept for that given equation. So let's look at this example, negative 2x minus 5y is equal to 10. In order for us to solve for the x-intercept, let's substitute y is equal to 0. So what I've done is I've replaced the letter y with 0, as you can see here. We know that any number multiplied by 0 is equal to 0, so hence you're going to get negative 2x is equal to 10. Let's now divide both sides by negative 2 to solve for x. Hence, x in this example is going to be equal to negative 5. So that's going to be our x-intercept. Now, in order for us to work out the y-intercept, we'll substitute x is equal to 0. So therefore, any number multiplied by 0 is equal to 0. You're now left with negative 5y is equal to 10. Divide both sides by negative 5 to solve for y. Hence, y is going to be equal to negative 2. And that's going to be our y-intercept. Let's now graph this equation. So what we'll do is we'll just plot both the x and y intercepts onto the Cartesian plane, and we'll now draw a straight line between these 2 coordinates, and that's going to be the graph of negative 2x minus 5y is equal to 10. This is going to be the second last thing that I'm going to be talking about in this video, so please bear along with me. What I'm going to show you now is how do we actually find out what is the gradient from the standard form. So the way that we do this is we need to actually rearrange the equation to make y the subject. In other words, this essentially means convert the standard form into the slope-intercept form, into y is equal to mx plus c. The way that we do this is we need to move all the terms that don't contain the letter y onto the other side away from y. And then what we're going to do next is if there is a number in front of y, we'll just divide all terms by that particular coefficient and then state what is the gradient for that particular equation. So in this example over here, 2x plus 3y is equal to 3. Let's move 2x to the other side. So to undo 2x, we'll subtract both sides by 2x. So therefore, my equation will now look like 3y is equal to negative 2x plus 3. Now, because I've got the 3 in front of y, I'll divide all terms in the equation by 3. So if I divide everything by 3, my new equation should now look like y is equal to negative 2x on 3 plus 1, because 3 divided by 3 is equal to 1. Now that I've successfully converted the standard form into the y is equal to mx plus c form, I can readily tell what is my gradient by the value of m, which is the number in front of x. The number in front of x in this example is going to be equal to negative 2 on 3, so that's going to be the gradient for this particular equation. Now, the last thing I want to talk about in today's lesson is showing you guys linear equations that only have like one singular intercept, whether that is the x-intercept or the y-intercept. So when equations are expressed in the y is equal to a form, you're only going to have a y-intercept. So in this equation, when it's y is equal to 2, you'll just have a y-intercept of 0, 2 in this example over here. Now, when the equation is expressed where x is the subject, then you're just going to have one singular x-intercept, as you can see over here. But when equations are expressed in the y is equal to ax form, okay, so it's very similar to the y is equal to mx plus c, but in this case c is equal to 0, you will have a straight line that passes through diagonally through the origin, okay? So what I would like you to do now is I'd like you to please answer questions 3, 4, 5, 6, and 8 from exercise 1F. Hopefully this video has been helpful and you're able to therefore meet the success criteria of today's lesson. Thank you for watching, and I'll see you guys again in the next one. Bye.